Okay, to start off, I would like you to count how many students there are in this room, and Zayna just went to the bathroom, so we'll also count her. Okay? So we need to add one for Andrina. Count how many students we have in the classroom. Students. How many did you get, including Andrina? 30. Good. Okay, what is the probability if I took all of your names and put them in a randomizer and pulled one out, what's the probability that your name is chosen? 1 out of 3, unless your name is Chris. If I only put in your first name, what's the probability that one of their names is going to be chosen? 2 out of 30, which is 1 out of 15. So for most of you guys, it's 1 out of 30. Okay, the 1 represents the number of favorable outcomes over 30, which is the number of total possible outcomes. Number of total possible outcomes. But if your name is Chris, your probability that we get Chris is 2 out of 30, which is 1 out of 1 out of 15. I'm going to caution you on your end. Did you not get one? Okay, come over here. I pray they fix this on the end of your stage test. Last year on the end of your stage test, they never put directions on probability. There are 3 ways to write a probability: fractions, decimal, and percent. And on the directions for what the stage, where there weren't any directions other than what is the probability, and never told the students how they wanted the probability to be typed in. Remember how it's not multiple choice anymore? You have to hand type everything? And every single class there's someone that said, Ms. Gray, the percent button's not working, or Ms. Gray, the fraction bar is not working. Because the computer would only accept the decimal version. But the directions weren't there. They never said in decimal form what is the probability. So, I'm going to give you a warning now. Probably, hopefully they fixed it, I don't know, but that drove me crazy because I saw so many people have the right answer, but I just had to say, I'm sorry, I can't help you. Okay, so many people had the right answer, but they weren't typing it in decimal form, and the decimal form is the only form the computer would take. So what would the decimal form of 1 out of 30 be? Okay, right, repeating. So if on a stage test, we had to type this in. The first one, we would put 0.03 repeating, if they allow for a repeating bar. And then 1 out of 15, how would you type that one in? 0.06 repeating. And the only reason there's a 7 on your calculator screen is because it ran out of room and rounded up. Okay? So, I hope they fix that, and I hope they're better at actually giving directions on the stage test, because last year, the directions were really lacking. Okay. Now, on a regular die, let's see. How many sides are in a regular die? 6. Okay? So what's the probability that I would roll a 2? 1 out of 6. There's only one side that has a 2 in here, right? Okay. So on a dice, we have this thing called sample space. The sample space is the set of all possible sides that could come up. So on a regular die, our sample space is 1, 2, 3, 4, 5, 6. It's the set of 1, 2, 3, 4, 5, 6. So a set is that collection So we put squiggly braces around them. Okay? And in total, there are 6 outcomes, right? Number of outcomes. And that would be the denominator for your probability. Yes, I think I still have all these guys. Yes, I'm going to give a few of these out. Raise your hand if you want. Okay, you two. You can have someone on this side. And show a few neighbors. Hey, one more person. Who else wants one? Okay, Alicia, couch. Okay, I think we're showing Alicia's first. There's a bunch of different dye out there. The tan one, which is what Alicia has. Alicia, take a look at that. And look at the sample space. Where's my paper so I know what it is? Okay. What does the sample space look like too? Okay, so 1, 2, 3, and we can go dot, 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 dot. 28, 29, 30. So the probability changes when we add more sides, right? In this case, what's the probability that we roll a 2? 1 out of 30, because the total number of outcomes now is 30. On that die, what's the probability that you roll an even? How many evens are there in 1 through 30? Half of them, 15 out of 30. What's the probability that you roll an even on that regular die somewhere? 3 out of 6, which is also 1/2. So even though the dice are different, probability of rolling an even is the same on this die as it is with Alicia's die. Okay, where's the light blue one? Yep. Okay. Can you see what the sample space is for that one? So what? Yeah, so 0 then counts by 10, 20, dot, 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 80, 90. Okay, this is a little tricky. How many total possible outcomes are there? Is it 9 or is it 10? 10, because we include the 0 as an outcome. So we have 10 possible outcomes though in your denominator. Okay, so on Jocelyn's dice, what's the probability of rolling an even? What? Out of? 9 out of 10. Why is it not 10 out of 10? 0, not even. So, everything else is even though. Okay, dark blue, where's the dark blue one? Okay, we want to see what's the sample space. The sample space is a collection of the listing of the sites. What's the smallest number you see there? 1, and then it counts by yeah, I think it counts natural numbers all the way up to what's the highest one? On the next one? I thought it was 20. Is it really 30? You sure you're not looking at 13? I don't see a 30 on this. Oh, you have a big dark blue. Oh. Does anyone have a small dark blue? Okay, Christine, that's yours. Okay, so big dark blue. Okay, so it's 1, 2, 3 to all the way to 30. So it looks like that is the exact same as the tan die. Okay, let's do the small dark blue. Christine, look at that die. What does it count by? Yeah, 1 to 20. So 19, 20. So that total number of outcomes is 20. So the small dark blue probability of rolling an even, again, is 1 out of 2, 50%, or 0.5. All of these have had the same even probability except for the light blue. Or that was different. There was the light green. I think we have a dark green. Are those the same? I think they're different. That's a dark green, I think. This light green. Okay. Light green, what's your sample space? 0, then counting by ones, all the way up to 9. Okay, so number of outcomes is how many? 10. So it's very similar to the light blue, except we're not counting the multiples of 10. But different than the light blue probability that you roll even was 9 out of 10. This light green, the probability that you roll an even is what? How many evens are there? 4 out of 10, which is 0.4 or 40%. Okay? The dark green, let's do that one. Dark green. What's your sample space? 1 through 12. 11, 12. So there are 12 outcomes. What's your probability of rolling an even? 1/2. Okay? Alright, next. If I have everyone with a die, so I'll put it up here in this baggie. Okay, next. How many cards in the standard deck of cards without the jokers? 52. Okay, any more out there? Okay. I don't know if my jokers are still in here out there. There's one. Okay, what's the probability that I drew at random an ace of diamonds? 1 out of 52. Okay? Because we only want an ace of diamonds from here. What's the probability that I draw just any ace? 4 out of 52 or 1 out of 13. Because the cards go ace is like a 1 up through king. We have 3 royals, jack, queen, king after the 10. Okay, what's the probability that I would draw red at random? How many reds are in the deck of 52? 26 of them, because we have 13 diamonds, which are red, and 13 hearts, which are red. So 26 out of 52, or exactly half of the deck. Okay? So, probably as of that, we already wrote down that it's the number of favorable outcomes divided by the number of total possible outcomes. Okay, the number of favorable divided by the total number of possible outcomes. Okay, so we know we have 30 students in the class, including Andrea, who's now back. How many, what's the probability that I picked a girl at random? Remember, it's just students, don't count me. Okay? How many girl students are in here? I'm getting 17. So that probability would be 17 out of 30. Okay? So experimental probability. Experimental probability measures the likelihood, measures the likelihood, likelihood an event occurs based on results of an experiment. The likelihood an event occurs based on the results of an experiment. Okay? What we've just been saying is theoretical probability. Theoretical probability describes the likelihood of an event based on mathematical reasoning. Okay, describes the likelihood of an event happening based on mathematical reasoning. Mathematical reasoning. So that's all the probabilities you've been telling me about. These different die are theoretical probability. So if I took, let's do the big one with 30. Maybe I shouldn't do that. This is the one I was going to do. Here's the one that has 20 on it. This dark blue one that's smaller. It has 20. The numbers 1 through 20. Okay. What's the probability that I would roll a multiple of 3? We have to figure out how many multiples of 3 are there in this. This is 1 through 20. It's a small dark blue. How many multiples of 3 are on this side?
Sorry, interruption. Where you go to lunch, please remember to vote during lunch. Occasionally, most campuses if you're not sure of school, join us. Very fair we offer. Please remember this lunch approach. Thank you.
Okay. Yeah. There's not 7 on here because 7 times 3 is 21, and this side only goes to 20. So that means there's 6 multiples of 3. So our mathematical theoretical probability would be 6 out of 20, which if we simplify would be 3 out of 10. Or what's that percentage equivalent? 30%, and if our directions on the stage test are terrible again, we would type it in the computer as what? 0.3. Okay? So experimental probability, though, say I took this die and rolled it 100 times, and I tallied how many times out of that 100 I got a multiple of 3. And so say I got a multiple of 3, I don't know. But right, I'm not actually going to do it 100 times, but on my experiment, say I got a multiple of 3, 17 times out of the 100. Then my experimental probability would be if I recreated that same experiment and re-rolled my die for another 100 times, I would expect a multiple of 3 to show up 17% of the time. Okay? So it's based off the results of an experiment, which is different than theoretical probability. Theoretical is just the mathematical based probability. Okay? Flip it over to the next slide, please. Frequency tables. So a frequency table is a table that displays data to show how often an item appears in a category. Show how often an item appears in a category. Displays data to show how often an item appears in the category. So I did that experiment rolling this die 100 times. I have my category for non-multiples of 3 and my category for multiples of 3, and I just tally. Okay, that's a frequency table. The relative frequency is a formula. It's the frequency of each category, of the category, divided by the total frequency. Okay? And the probability distribution shows the probability of each possible outcome. Shows the probability of each possible outcome. And this is all displayed on one nice table, easy to read. Okay? We don't have time, unfortunately, to actually flip a coin a bunch of times. But if we were to toss a coin 3 times, what are some of the ways our 3 different tosses could end up? Heads, heads, heads. Okay, yep. Tails, tails, tails. What else can we get? Heads, tails, heads. How do you get heads, tails, tails? How do you get heads, heads, tails? Okay. Tail, heads, heads. What else? Tail, head, tail. How do we get tail, tail, heads? 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. I think we got all of them. Okay? So, because we actually did this experiment, and this is the frequency that we got each of these. For this frequency, we got heads, heads, heads 5 times. We got tails, tails, tails 10 times. We got heads, tails, heads 6 times. Heads, tail, tail 9 times. Heads, heads, tail 7 times. Tails, heads, heads 2 times. Tails, heads, tails 9 times. And tails, tails, heads 2 times. Okay, so that would be our frequency table right there. Just how many times they showed up. Relative frequency, actually, I'm going to do probability distribution first. I think that would work better. Probability distribution. Now the probability distribution shows the probability of each outcome. And can be shown in a frequency table. So how many rolls or different times did we do the experiment? I don't know. How many times did we do the experiment? 50. Okay, so the probability distribution is how many times did we get heads, heads, heads out of that 50? 5 out of 50, which is 1/10 of the time, or 0.1. How many times do we get tails, tails, tails? 10 out of 50, or 1/5. Okay, and these are the probability distributions. Okay, the next one would be 6 out of 50, or 3/25. The next one would be 9 out of 50. Does that simplify? No. 7 out of 50 also does not simplify. 2 out of 50 simplifies to 1/25. 9 out of 50. 2 out of 50 becomes 1 out of 25. These are the probability distributions. This the probability that we got would get each one if we recreated our experiment. Does that make sense? How you get probability distribution? Take the frequency divided by the total. Okay? Relative frequency. Okay, relative frequency, remember there's a formula. Frequency of the category over total frequency. Okay, so what's the relative frequency that we ran heads, heads, heads? Frequency of the category, how often this category heads, heads, heads. Oh, excuse me, I was going to do how that we have exactly 2 heads. Relative frequency that we have exactly 2 heads. Sorry. So you need to look at all of our categories. How many of them have exactly 2 heads? I think I see 4. Oh no, I guess this is not exactly 2 heads. This is at least 2 heads, huh? So 1, 2, 3 have exactly 2 heads. 3 out of the denominator is your total frequency. So in total, how many times did we have exactly 2 heads? In total, how many did we have exactly 2 heads? Yeah, 6 of them here. Yeah, how many here? And plus how many here? Oops. 15. Okay, so we divide by 3, top and bottom, we get our relative frequency is 1 out of 5. Okay. I should have left more room. That's the relative frequency, I'm just going to put this over here. Relative frequency that we get at least 2 heads. What's the relative frequency that we get at least 2 heads? At least 2 heads, could that mean 3 heads? The 3 heads, at least 2 heads? Yeah. So we have 1, 2, 3, 4. Out of how many total? Actually, I'm sorry. I think the denominator actually should be our total frequency, which was 50. This should have been a 50 instead of 15. Because we had total flips were 50. So 3 out of 50. And this one's 4 out of 50, which would be 2 out of 25. Okay, I think that's about as far as we can go because we only have a couple minutes to go. So 2 parts to your assignment comes from your book. Page 926, 1 through 4, 7 through 11. That's on your regular probability. And then these probability distributions is the second page. Do these together on the same paper or staple them together. Okay, 933, 1 through 12. Okay, and then we'll get a quiz on your quadratics next time. We will have a substitute next time because I'm going on a backpacking trip Thursday night. Has anyone been to Havasu Pie? You know, Boy Scouts? Most Boy Scouts do that. Oh, okay, well, that's anyway. So with yourself, you will be watching videos on volumes. We're going to switch gears, but we'll hit probability again on Tuesday, and if you can bring Skittles to make our activity more enjoyable, that would be great. You brought Skittles to share, to do the activity. Where the other joker went. Okay. Sean, stage test. Who was the other one? Alicia, stage test, right? That closes Friday. I cannot reopen it for you. So that is the deadline. If anyone has their stage test work, turn it in for the filters before you leave.